Good day, everyone. Welcome to a journey deep inside SQL Server's crystal ball, estimating between histogram ranges. In the world of database management and query optimization, few topics are as intriguing and essential as understanding how SQL Server predicts query outcomes when the data you are seeking falls in the gray area, right between the lines. Picture this. SQL Server isn't just a database engine. It's your data oracle, your fortune teller, and it wields a power tool, the statistics histogram. This histogram is like the crystal ball of your SQL Server instance, offering glimpses into your data's distribution and helping SQL Server make informed decisions about how to execute your queries. But what happens when your query's predicate value is neither a direct hit or a miss in the histogram? It's all if the crystal ball's vision blurs, and SQL Server has to rely on its best estimates to provide you with the results. In this video, we are going to peel back the curtain and shine a light on this fascinating aspect of SQL Server query optimization. We will demystify the intricate process of eliminating between histogram ranges. Whether you are a seasoned database administrator striving to fine-tune your SQL Server performance or a curious newcomer eager to understand the inner workings of databases, this journey is for you. Throughout this video, we will explore the techniques, algorithms, and strategies that SQL Server employs to handle these unique scenarios. We will answer questions like how does SQL Server estimate the number of rows to retrieve when your predicate value doesn't align perfectly with the histogram's range boundaries? What factors influence these estimations? And most importantly, how can you harness this knowledge to optimize your own queries? So, join us as we embark on this enlightening quest, equipping you with the skills to navigate the data landscape with confidence and precision. Whether you are a database wizard, a data analyst, or simply someone fascinated by intersection of technology and data, prepare to be captivated by the inner working of SQL Server. Without further ado, let's deep dive inside SQL Server's crystal ball, estimating between histogram ranges. Let's get started. We will discuss about the estimates as far as SQL Server query is concerned when the predicate value that is used by the query doesn't have a direct hit on the histogram step. That is like, for example, the value that we are using in the query. For example, if it is buried between the histogram step or if it is buried between the range high key, then we will discuss in this video like how will the estimate be done in that particular case. Okay, let's make sure like we don't have the execution plan enabled because I'm going to insert a lot of rows. So what I'm going to do is like I'm going to use database adventure works TW for this demo as well, and I'm going to insert some random rows into table 1. If you can see here, what I'm basically doing is like I'm trying to insert 53 rows here, 54 rows here, 55 rows. Likewise, I'm slowly inserting a lot of data inside this particular table, and also like I'm not incrementing everywhere. It is basically like it starts with 53 rows to 82 rows, like this many number of rows will be inserted, and after that I'm again doing it from 53. So likewise I'm doing the insert onto this particular table just to make sure I get some sort of data to work with, and also like there are some skews as far as the data distribution is concerned. So what I'll do now is like I will insert all these rows, and each of these insert statement is going to insert multiple rows onto table 1. Yep. And now if I have the execution plan enabled for these inserts, then it's gonna take more time. That's the reason I'm making sure like the execution plan is not enabled. So what we'll do now is like we will execute this particular query here. And once this query completes, we will check these queries. So the first query that I'll be checking is this one, where I'm checking the number of rows on table 1 with the predicate column 4 is equal to 11 January 2024 around 2032. Yep, so it's in future date, but let's look at it like what we have. So now what I'll do is like I will enable the actual execution plan, and then let's execute that. So what I'm seeing is like I've returned close to 3000 rows. The count for this particular predicate is close to 3000. That is, we have 3000 rows with this particular value, which is 11 January 2024. 8:32 p.m. Yep. Now let's go to the execution plan, and in this case, what I'm seeing is like I'm getting a cluster index scan on the table 1. Let's hover our mouse on this particular operator, and what I'm able to see is like I'm able to see close to 3000 rows on as the estimate. So the estimated number of rows for all execution is 3000. And what we'll do again is like we will execute this query now, and then let's note down the estimate, and then we will understand from where these estimates came. So this query, I'm looking for the count from table 1 for the predicate column 4, 11 January 2024, and this time the value is 8 p 8 p.m. 30 yeah 8 p.m. 8:32 p.m. Yep, that's the what I'm looking for. So if we look at it here, both these two queries, yeah, what I'm able to understand is like it is kind of same, only the only difference is like there is an seconds and milliseconds difference, yeah. So there is like this one is this first query is like has a predicate of 11 January 2024, 8:32 p.m. 6 seconds. So the second one is like 11 January 2024. It is 8:32 p.m. but the seconds use is 0.5. So that's the difference between these two queries. So let's execute these two queries at the same time. The first query returns 3000 rows, and the second query returns 99 rows. Yeah. Now let's look at the estimates here for the cluster index scan. For the first query, I'm estimating 3000 rows, and I'm returning 3000 rows because the actual number of rows for all execution is 3000 if you're looking at here. And for the second query, what I'm basically doing is like I'm estimating close to 80 rows, and I'm returning close to 99 rows. So the estimated number of rows for all execution is 80, and then the actual number of rows for all execution is 99. So the estimate for the second query is 80. So let's put that here. And then what we'll do is like we will check the available statistics on table 1 and see like what statistics we have on column 4. And for column 4, we're able to see this particular statistics here. Let's take that statistics, and then let's run that. So the value that we have used in the predicate is 2024. So let's go to the date 2024. So if we see here, we are able to see like the 200 step of the histogram is 2024. We don't have anything else as 2024. And now if I look at the value here, the range high key here, it basically tells like it is 11 January 2024. 8:32 p.m. 6 seconds, which is same as this one. So for this query, we have a direct hit on the histogram step. If you see this one, the value of this one and this one is one and the same. It is basically the same value. So luckily for this particular query, we are able to get a direct histogram step hit. So that means like for this one, it basically uses the EQ rows, which is close to 3000, and that's the same thing that we saw, yeah, which is equivalent to 3000. And as far as the second query is concerned, which is 11 January 2024, 8:32 p.m. 5 seconds, we don't have a direct hit. Instead, that value is basically buried between step 199 and 200. That is, this particular value that we are seeing here is basically buried between this value and this value. So in this case, what we basically do is like we look at the average range rows, and in our case it is basically 80, and that is what we are seeing here. So now what I'm going to do, I'm going to execute these queries side by side, and then we will look at the estimates. Yep. So now if we look at it here, for the first query I'm able to see 3000 estimate. The estimated number of rows for all execution is 3000, and for the second query I'm able to see the estimated number of rows for all execution is 80, which is same as what I mentioned here. The first query 3000 and second query is 80. Now if I go back to the histogram step, here, the last step, that is the 200 step, is basically a direct hit for the first query. Like the column 4, whatever value that I'm seeing here is basically seen here. So I'm going to use the EQ rows, which is 3000, and that is where I got the value. And the second value is concerned, it is basically buried between 199 and 200 step, between these two, and hence I'm going to use the average range rows, which is 80, and that is where I got the estimate here. So this is how we basically we, in the sense, the SQL Server optimizer is going to do the estimate and create the execution plan. That's it for this video. Thanks for watching. Have a great day. Jai Hind.